All right, that'll work. There we go. Good little dude. All right. So we're going to get into probability. And just to make you realize, on the homework sheet I've got, the one quiz I've got listed is something I call a double quiz. Probability is sort of its own standalone thing, in a way. So I sort of give it its own little, I used to call it a mini test, but then that freaked people out. It's a double quiz because it's twice as long and counts twice as much as a regular quiz. Everybody cool with that?
Well, the quiz we took already?
Say again?
The quiz we took already was the double quiz?
No. The double quiz, as listed on the homework sheet, will be on chapter 4, probability. Or chapter 3. I like that. Okay. So see, we already talked a little bit about some probability stuff. We did the whole birthday thing. Right? We did the whole Monty Hall, not Monty Hall anymore, but the Let's Make a Deal, the doors, picking a door and there's a goat or not a spider goat. And my point with that was to show you that probability is not instinctual. Right? It doesn't come naturally to us in a lot of ways. So we need to rely on the concept to get to somewhere. We can't just kind of guess at it. But let me see what you guys already know about probability. So, how many people in here are left-handed? Anybody left-handed? 1, 2, 3, 4, 5. Okay? There's 5 left-handed people. Out of, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 28, 30, 32, 34, 36, 38. I think it's 40. So what's the probability? If I picked one person, what's the probability I get a left-handed person out of this class? So you got to read this. One thing is the notation that we use. This means the probability I pick somebody who's left-handed will be again?
12.5%.
Yeah, sure, but how'd you get there?
5
out of 40. All right, so that's the basic idea of probability. It actually never changes. On the top goes the number that matches what I'm looking for. I got 5 chances to get a left-handed person out of 40 chances to get a person. Right? That's how any probability works, believe it or not. Okay. So let me kind of build a problem you'll definitely see from me on the probability quiz and on the final exam. Let's say that I ask a question, some men and some women. I ask this question, and the answers are yes, no, unsure. What question did I ask them? I don't know. Make up your own. So if I do this, can anybody tell me how many men said no? How many men said no? 41. 11. How many total people were not sure? 8. 11. Okay, good. So one level, I always have a few people that aren't able to read this chart. And if you're not able to read this chart, you're not going to be able to answer any questions I ask about it. Right? Since probability is based off of totals, the denominator is always going to be the total number of things that could happen. It makes sense to kind of total everything up. So I've got 37 people said yes, 52 people said no, 8 people on the fence, 52 men, and 45 women. Now the next mistake I see, what number should go here? This number should represent what? All the people. But I have people that do this plus these. What's wrong with that? You counted everybody twice. You counted everybody twice. What the shit? So the right way to do this is to say, okay, that's 97, and then just double check. This better also be 97. Thank God it is. Okay, all right. So make sure if you can't work this chart, you're never going to be able to answer the probability questions that I'm going to ask you. So I could ask you a question like this. So if I pick one person, what's the probability I pick a woman?
45 out of 97.
Yeah, 45 women. 45 things that match what I'm looking for out of 97 total things that could happen. A lot. And what is that? Somebody help me out.
Looking for women out of the whole group.
What's 45 divided by 97?
About 46%.
Give me 4 places.
46.3918%.
4639? Okay. All right, hopefully rounded correctly. So probabilities, I want to get you ready for later. We're going to use a chart later this semester that gives me probabilities to 4 decimal places. I want to get you used to that. So all the probabilities, I want them decimals 4 decimal places. So you could make this into a percentage. Hello. Okay, so I could ask similar, should be easy questions like, what's probably I get somebody who said no. $52 out of 97. I like it. And then, whatever the hell that is, probably about 53%. If anybody can help me, that'd be great. Six zero? 6-1? Okay. 6-0 something, and then round correctly. Okay, cool. And then you could make it like this if you want to. I don't personally care. You can leave it like this, put it like that. I don't care. So on these problems, I know I'm the crazy math instructor who doesn't use Scantrons and wants to actually see your work. Work on these problems is this. This is the idea. This is the work. After this, yeah, I want you to take it at 4 decimal places. You can make a percentage if you want to. This is the work, though. Don't skip this shit. Because even if you put the right number down, I don't see the work, you're losing points. Okay, maybe. So let me ask a little more interesting question. What is the probability that I pick a man or somebody who said yes? So remember, the top of a probability is the total number of things, in this case people, that matches what I'm looking for. So, yes?
81 over 97.
All right, let's build up how to get there. I always call or the nice bouncer, and is the mean bouncer. Or is the bouncer, I come up to the club, and the bouncer says to me, what the hell? The only way in here is you got to dress nice, or you got to drive a good car, or you got to know Joe. I know Joe, I'm in. Yay, nice bouncer. I just have to meet one of those requirements. This or this or this. So how many people, more people can get into that club? And would be the bouncer that says, you got to know Joe. I know Joe, and you got to dress nice, and you got to have a nice, all right, I'm out. You guys kind of with me on that? So, and probability questions will always shrink the number because less and less people meet the requirements, or lets more and more people in. So that's why this one is going to make sense, that it's going to be a bigger number than man or yes alone, Because I'm looking for men or people that said yes. Now, what's wrong with this? What's wrong with saying, okay, there's 52 men, and there are 37 people that said yes, and then just divide that by 97. What's wrong with that? That is wrong.
You're doubling up on the yes men.
Yeah, I like it, the yes men. So, if I count all these people here, and all these people here, how many have I counted twice? 8 of them. 11. And on this specific problem, it doesn't quite work here. Oh, well, 2. You never want a number that's bigger than 1. Dear Lord, the quickest way to make me cry on a probability question is to get an answer like 115%. Circle that sucker and keep going. Numbers mean something, right? What the hell does 115% chance mean? 115% chance of rain. Are the drops like huge or something? One drop is going to like destroy your car. Bam! Oh shit! I forgot it was 115% chance of rain today. Do you guys understand? We all understand, but you guys don't match up the math with the idea. You get a number, you circle that shit, you keep going. No! If you have no idea what you did wrong, at least say, I know it shouldn't be more than 100%. I'll give you something for that. If you just circle that thing, I'm like, holy shit. All right. Same thing goes for negative probability. That's freaky as all hell. It's so not going to happen. Okay. So what should I do here? How could I correct that without erasing anything? Yeah, how many people did I count twice? 8. So let me just subtract 8. Now, a smarter way to do this is to say there's 52 men. How many yes people did I not count yet? 29, and just add those directly. But what is 37 minus 8? Of course, it's 29. Right? So the math doesn't give a shit which way you do it. Just make sure you don't double count anybody. How are we doing so far? All right, so expect OR probabilities to make the numbers bigger than they would be on their own, and probabilities will make the numbers smaller. So what is this? Let's see.
0.8351.
I like it. So trusting. Okay. All right, I like it. Oh yeah, like I said earlier, you can just leave it here, or you can make it a percentage. It's up to you. What I'm going to say on the quiz or on the test would be round all decimals to 4 places. You can then convert them to a percentage if you want to. Yeah, but I want to take it out to 4 decimal places. I like it. Remember what I said early on in the semester? I said if you just take everything to 4 places. Because what standard deviation got to be? To at least 3. So if you take it to 4, you're golden. Right? Okay, maybe. Okay. So what about, let's do an and question then. I don't want to take any of this away. I might ask something about these. Let's say, what's probably that I picked somebody who said yes, and they're a woman. So to be included, not only do you have to have said yes, but you also have to be a woman. How many people do both? 29. And another name for and in mathematics is intersection. And look how that makes sense with the chart. What's the intersection of yes and woman? 29. And isn't that a smaller number than either one is on their own? I like it. So this would just be 29 out of what? Yeah. What's the only way the bottom number could change? This is a weird question to throw at you, I know. Why is the bottom 97 for everything we've done so far? Because who could I pick? How many people could I pick? 97. There's 97 people I could pick, right? So the only way that number could get smaller, it can't get bigger unless the people just spontaneously, reproduce. Boom. I didn't know I could do that. Okay, that would, it's outside the bounds of this class. But the bottom could definitely get smaller. Let me show you an example. Real quick, what is 29 divided by 97?
0.2990.
Oh, it's almost 3. So here's a key word in this question. Let's see if you guys pick up on it. So the probability I pick a man, given, they said, what you got, Jeff? Unsure. I like it. What do I know about this person based on what's stated up here? What's this question say? Find the probability that it's a man. So I have no idea if it's a man. Find the probability it's a man. Given they freaking said unsure. So that's what I know. So how many people am I talking about? 8 people. So your whole world becomes this column, basically. Out of those 8, how many match what I'm looking for? 3. So 3 out of 8. So what's the only way the bottom can change is if I give you information about who it is I picked. I know they said they were unsure. I just don't know if they're a man or not. What's probably they're a man? 3 out of 8. Coolness, which of course is okay, cool. I like it. Not too bad. So let me, before we break down what these formulas are, let me recreate this. I'm going to do another chart and have you guys answer a bunch of questions like these on your own. Okay. Has everybody got all this stuff? Yes. Okay. Let's see. Jeff, let's just do this. So let's see. There's no maybe. Let's see. All right, so there's that. Here's the questions. Let's just do those 3 for right now. don't really mean to make it 100, but that makes it a lot easier. These are pretty much you get it or you don't situation, right? So what's that probably? I pick somebody who's under 21. Yeah, 51 and 100, 51%. A lot. Probably that I get somebody who said maybe, or they're 21 and up. Yeah, what's the quick way to do it? There's 49 people that are 21 and up. How many maybes have I not counted yet? 3. I like it. But for the purposes of what I'm doing next, let me do it the long way. So I could say the maybes are 12. The 21 and up are 49. And then I counted 9 people twice. So you get, what do you say, 52? Yeah. I like it. Might as well just move over here, but should it? But yeah, it's totally. All right, I want you to realize something. What I'm about to do after we're done with these questions is I'm going to develop formulas for each of these. Did I need formulas? Did any of us need formulas to do this? No. I love this problem because if I give you the situation, you can just count everything. You don't need the formulas, obviously. We just did all this shit without any formulas. Just using the basic idea. If I don't give you stuff that you can count, then you need the formulas. So what I want to do is I want to finish this, we'll develop the formulas, and then I'll show you a problem where you have to use the formulas. What about this guy? What goes on the bottom now? Yeah, 36 goes on the bottom. Because what do I know about this person? I know, given they said yes. So now my whole world is this. And out of those, how many match what I'm looking for? 7. And then, whatever the hell that is. 0.19. What is it? 1944. Let me ask one more question. I forgot to ask. What's the one kind of question I didn't put up here? And. I love it. So let's do an and real quick. Just because. Of course, the and being there sucks, but oh well. It's probably I picked somebody who said no, and they're 21 and up. So they have to say no and be 21 or over. How many did that? How many people said no and they're 21 and up? 11. Yeah. So again, it's the idea of intersection. It's a really cool idea. Bam. Out of what? Beautiful. The bottom only changes if I give you information. I didn't get any information here. Okay, so let's talk about the formulas. And then we'll do an example where you have to use the formulas. I'm going to take this away. So look at the OR here. What was 12 over 100? Where did that come from? Yeah, that's probably a maybe. What's 49 over 100? Yeah, 21 and up, right? And then what's the 9 out of 100?
Probability of both of those things happening.
Good. The and of those two things. Which kind of makes sense. If I add all the, the maybes to these guys, I've got to subtract anybody who were both, because that's the people that I counted twice. So this would be minus the probability of maybe and 21 up. So in general, the formula for OR is addition with a little modification at the end. So what is the probability of event A or event B? It's going to be the probability of A plus the probability of B minus the probability of A and I lock it. Yes?
Are you going to use union symbols? Write out and or.
Yeah, I'm going to write out and or. Kind of matches the book. The given, I'm going to use a symbol here in a minute. Yeah. Okay, now what about the given problem? So everybody got this guy. This is huge. This is going to be sitting on our formula sheets. And I want to remind you, did I need this formula to do any work we did? No. We created the formula based on what the hell we did. That was based on the basic idea of probability. So when I give you a chart problem, don't force everything into a formula. You can just count shit. You never hear a math person say this, but the formulas get in your way if I can count everything. I don't need them. Maybe. Have you ever heard a math person say that? No. But statistics is not just pure math. There are situations where the formulas make it worse. And the reason that is formulas have to be unbelievably general. And if I have a specific situation, I don't need them. I just see exactly what I need. So let's look at the given. Let's see if I can do this. What went... Let me show you the symbol here, because I'm going to use this symbol. Here's a symbol for given as a straight up and down line. It's an unfortunate symbol because it looks like divided. When you see this line like this, you read it as given. Probability of A, given that B happened. So what do we put on the bottom? Where did this come from? Where did that 36 come from? The yes people, the given thing, right? So on the bottom is going to be the B stuff. The given thing is going to go on the bottom. Now, what was 7? 7 wasn't the people that were under 21. What was 7? Look back at the chart, hopefully, that you wrote down. What was 7? Yes, but I need a word in there, a specific word. They said yes, and they were under 21. And watch this. Here's a beautiful little picture. You ready? Have you guys seen Venn diagrams before? Oh, shit. You guys have seen this kind of thing before? Venn diagram? And you're like, yeah, I've seen circles, man. No, it's in there. So in this case, I know that B happened. I know B happened. So whoever this guy is, no, he's got no chance. This guy, no chance. So what's the only way that A could also happen? Where would it have to be? What's the only A's that have a chance to have happened is these guys. And what is that? That's the part that is A and B. Maybe. So there's a formula for given. That formula looks disgusting. It looks much harder than what we did because we had a specific situation where I could just count what I needed. I didn't need a formula. So the only thing we're missing so far, we got a formula for OR. You're going to hear me say this a lot. OR is basically add. Why do I say basically? Because there's that minus thing to adjust if there's an overlap. Because then I counted some people twice. So we still have to do AND. I don't know what the formula is for AND. The funny thing is I've got an algebraic way to get it. Is there an AND statement in here? Yes, right there. Can you solve for this? If I solve for that, I have a formula for AND. I love you guys. This is the whole point of algebra. Or one big point of algebra is, can you manipulate symbols? Because what do you do when you do that? You create other formulas that are useful. So how do I solve for this? Yes? Yes. Just what? Yeah. There's stupid things here. I don't like it. Let me multiply the hell out of it. So what's the probability of A and B? It's probability of B times probability of A given B. Or, I could have switched these around. It's the probability of A times the probability of B given A. Now this formula we definitely did not use. Holy shit. If I give you something you can count how you do the AND, you just see the number that's in both. You're not going to use this crazy ass formula unless you hit a situation where you have to, where you don't have stuff to count. So for example, if I said this, we know probability of A is 0.7. Probability of what do you got, Jeff? B given A is 0.5. What's the probability of A and B? So this sounds a lot more like algebra, where we have a formula that exists, and I gave you some values, and you just plug that shit in. This should feel very familiar. Do you see why there's two different ways to write this? Which one of these do I want to use, of course, the top one or the bottom one? Probably the one that I know stuff about, right? So the bottom one. Do you guys see that? I always get somebody who's like, I don't know, and we'll just use this one then. They're both the same thing. They both lead you to the same thing. So how do you use this? It's going to be what? .7 times 0.5. Okay. So that's the kind of problem. If I don't give you, you can count all the things involved. You don't even know what the hell A and B are. I just give you numbers. Okay, then you've got to use a formula. It's the one time you should actually use the formulas. What if I then ask you this? Now find the probability of A given B. What am I missing to be able to do that?
Probability B.
Yeah, probability B. What's the formula for this? It's going to be probably A and B. I got that divided by the probability of B. This is what I don't have. So I wouldn't ask you this question. I just want to show you. When I ask you a question, you write the formula that would give you that, and then you step back and see, do I have everything? All right? Now this would be an unfair question because I didn't tell you the probability of B. I didn't give you a way to discover it. But let me add one piece of information. New information. Oh shit, now I gotta make things work. Let's see. Yeah, okay. Should work. Let's see how it works. So I tell you that. Oh shit, this is so mean, I don't care. I'm telling you that what I just told you gives you the way to get the probability of B. Take a minute or two and try and see if you can get the probability of B. It's a formula that's not still up here. Right, doesn't the probability of A or B have its own formula? So maybe you write that sucker down and see what values you know. That's a good place to start. Write the formula down related to what I've told you. So if I ask you a question, write a formula down for what that is. If I give you information, write the formula down for what that is. Then you can really see what it is you know, what it is you need to know. That's how a lot of mathematics works once those formulas exist. Is that still going? Is he taking his break yet?